Hey everyone, and welcome to The Explainer. Today, we are tackling something absolutely crucial. Seriously, it's a foundational, incredibly powerful skill in Python programming, extracting and manipulating text data using strings. I mean, have you ever wondered how a system instantly generates a clean username from a completely messy email? Or how a search engine instantly pulls the exact right word out of a massive document? Well, you are definitely in the right place. Let's visually break down exactly how Python handles text, literally slice by slice.
Okay, let's dive into this. Here is our flight plan for today. We're going to start with the anatomy of strings, move right into the art of extraction, look at transforming your text, and finally, we'll wrap up with tracing code and avoiding those common programming traps.
So Section 1, the anatomy of strings.
Now, to manipulate a piece of text, say a file named student2026_report.pdf, we first really need to break this illusion that a word is just a single indivisible entity. It's not. A substring is simply a smaller section taken from a larger string. And in the real world, honestly, programs rarely process whole values. Think about it. If you have a massive data set of file names, you probably just want the file extension, right? So extracting these substrings is absolutely the crucial first step.
But to actually grab those smaller sections, we have to understand how Python looks at a word. It sees it as an ordered sequence of characters, and each one has a designated position. We call that an index. Now, notice the really crucial detail here on the bottom row. Counting starts at 0, not 1. I know, it's a little weird at first, but the letter P is at index 0, the Y is at index 1, all the way down to the N at index 5. Keeping this zero index rule in your head is going to be key.
Let's move to and see how this builds. Section 2, the art of extraction. This is where we learn how to perform actual surgery on our text.
All right, this brings us to what I like to call the golden rule of Python slicing. Ready? Start is included, end is excluded. Make it your new rhythmic mantra. When we extract or slice a string, we give the computer a start position and an end position. But here is the catch. Python will always stop pulling characters just before that end index.
And this brilliantly illustrates exactly how that rule works in practice. So we have the word computer mapped out here with its index numbers, 0 through 7. Say we want to extract a slice using the code text bracket 2:6. Okay, we start at index 2, which is the letter M, and that is included. We grab the P, the U, and the T at index 5. Then we hit index 6, the E. And since our AND is excluded, we stop right there. The resulting substring is perfectly sliced as MPUT.
Moving right along, Section 3, transforming your text. Because once you've surgically extracted a substring, you can manipulate it, kind of like Dr. Frankenstein piecing something completely new together.
So now that we have our extracted substring, what do we actually do with it? Well, there are 3 core ways we can manipulate our text to build that new piece. First, we can concatenate. That's just a fancy word for joining strings together, like combining a first name Ada with a last name Lovelace. Second, we can alter the text's visual appearance. And third, we can replace specific sections entirely.
Let's compare altering and replacing for a second. On the left, we take a lowercase string IBDP and we run the method code.upper. This instantly transforms it into an uppercase IBDP, which is incredibly useful for standardizing messy user input. Then on the right, we're replacing text to clean up bad data. If an email is saved as sam-school.org, using replace dash for the @ symbol just swaps out that incorrect dash. Easy, right?
Okay, let's tie all of this together in a complete real-world scenario. Imagine you're building a system for a school, and you literally have to generate clean usernames from a huge list of long, messy email addresses. Here's how it works. Step 1, we store the email maria.lopez@school.org. Step 2, we use our new extraction skills. By slicing from 0 to 11, we pull out just the maria.lopez part. Step 3, we clean it up by replacing that dot with an underscore, giving us maria_Lopez. Step 4, we concatenate. We just join the label username with our newly clean name. And finally, step 5, our beautiful final output is username maria_Lopez. It's extraction, replacement, and concatenation, all working together in perfect harmony.
Which brings us to our final part today, Section 4, tracing and common traps.
Now, what's really interesting about this slide is how it shows that writing code is one thing, but predicting its outcome is what makes you a true programmer. Notice how a trace table turns the abstract, invisible flow of code into a highly predictable, logical story. It literally tracks the computer's memory at each step. So we start with the title Annual Report 2026. Next, we slice it, and the new variable word holds report. Then we use the upper method, so our short variable holds report in all caps. Finally, we concatenate, creating final underscore text which equals report ready. Tracing it step by step like this just ensures your program does exactly what you intend.
But hey, even the best of us make mistakes. So here are the most common traps to watch out for. First up, getting the end position wrong because you forgot that the end index is excluded. Happens all the time. Second, confusing the index position with the overall length of the string. Third, updating a variable but accidentally printing the original one. Oh, and finally, and this is a big one, forgetting that in Python, strings are immutable. Things like replace or upper do not change the original string. They create a brand new one entirely. If you don't save that new string to a variable, your change just disappears into the void.
And that brings us to our conclusion. But before you go, I want to leave you with a quick challenge to test your new dissection skills. If you were given the string data equals candidate 4587 HL, what exact start and end indices do you need to extract just the numbers 4587? Remember to start counting at 0, and remember the golden rule about that end position. Map it out, and you'll realize just how much control you now have over your data. Thanks so much for joining me on this explainer, and keep coding.